Hi, today we've got the first in a series of videos of me upgrading my home network and server, and to start off with we're going to be looking at the internet gateway. So for a couple of years I've been running one of these Watchguard Firebox units in my network cabinet as my home router. Rather than using the software that comes on these devices that you have to pay a subscription for, I decided to run pfSense on here. So this is basically just a standard PC with a customised motherboard which allows some extra gigabit ports on the front. It's got an interface for an LCD and then also a COM port on the front which offers console redirection, so you can completely configure the device over a serial port. So as this is basically just a standard PC, the main problem with it is that it's drawing quite a lot of power from the mains. So I changed the processor to a Celeron M to try and get the power consumption down a little bit, but the power consumption is between 35 and 55 watts depending on what it's doing, which is quite a reasonable amount just to have this running all the time. So what I've done is I've purchased a new device. This is a MikroTik router board. And these come in various form factors, so you can get them in desktop form factors or the rack mount, which is the type that I've bought. And this is a dedicated piece of hardware which should have much lower power consumption. I haven't really used the software yet. There are some demos online. Basically you can log in and have a play with the software. But I'm hoping that this is going to get the current consumption down, and also I don't think it's got any fans in there, so it should be a bit quieter as well. So to start off with, we'll have a look under the hood of the old Watchguard unit, and then we'll have a look at the new device. Right, so here we have the front of the Firebox. This is actually my spare unit. I've got another one in the network cabinet which is running the internet, and I picked up a second one of these off eBay just in case something happened and I needed to get the internet back up and running as soon as possible. So I think I bought both of these for £30 each or something like that. This one's the Watchguard Firebox X750E, and the one that's in the network cabinet as my main one is the X1250E, which is a slightly higher model. I think it's just the processor that's really upgraded. If you're running the original software, the software was slightly more fully fledged on the 1250E, but if you're running pfSense, it made no difference. So the device is running at the moment. I don't know if it's being picked up on the shotgun microphone, but it's really quite noisy. You can see on the front here we've got the 8 gigabit Ethernet ports, we've got a couple of indicator LEDs, the serial port which you can use to configure the device. There's 4 buttons here which aren't really used if you're using pfSense, and then you've got the LCD on the left. And then if we have a look at the rear of the device, we've got the mains inlet on the right, a power switch, and then the reason that the device is so noisy is that it's got 3 40mm fans. So they're basically limited by the form factor of the device. So this is only a 1 unit high rack mount unit. So the biggest fans that they could use is 40mm fans, which have to spin at quite a high speed to get any airflow through the device. So you get quite a noisy device at the end of it. And then just on the left hand side here, there's an option slot so you can fit a dedicated hardware VPN card just to take the load off the processor if you've got lots of VPN clients. So let's have a look inside the unit and see what we've got. Right, so I've just lifted the cover on the device and immediately you can see the motherboard takes up the majority of space inside the unit. On the right hand side here we've got an ATX power supply in an open frame package. We've got a 20-pin ATX connector here and a 4-pin connector for 12 volts. We've got a couple of sticks of RAM here. This is DDR2, 512 megabytes per stick. We've got the processor, heatsink and processor under a little cowl here which is directing airflow through the heatsink to 2 of the 40mm fans at the back. We've got the North bridge and South bridge. We've got the BIOS chips here, and then some Marvel chips for the gigabit Ethernet ports. And then you can actually see that 4 of these ports must be optional extras because these are on a expansion card. And then we've got the expansion here for the VPN card. And this looks like a PCIe slot. And I think I can see PCIe X4 written on the board here. So this must be just a standard PCI slot. And then we've also got a 40-pin connector here which says IDE 2, so I don't know if you can add an IDE hard drive to this as well as the compact flash which is running the software. Right, so I'm not going to do an in-depth teardown or anything like that on the device, but we'll have a look at a few things under the hood. So we've got the open frame ATX power supply here. This is a 250 watt model from Channel Well Technology in China, and it can supply 30 amps on the 5 volt rail and 14 on the 12 volt rail, so definitely worth salvaging this if I decide to scrap the unit. But on the left hand side here we've got a 12 volt connector, 4-pin connector for the processor, and then the 20-pin ATX connector, but no connectors for any hard drives or anything like that. So if I did decide to use this in another PC, I'd probably need to solder those onto the board. And then you can see there's some material here. I think this is thermal pad. It seemed quite warm just after I turned off the device, even though it was only on for a few minutes. So it looks like they're probably using the top cover as a heat spreader just to get a bit more of the heat out through the fan here. It also probably provides a bit of electrical isolation so that if you're pressing down on the lid, nothing shorts out. And then on the right hand side here we've got the mains inlet, the mains switch, and then that just goes straight into the 2-pin connector on this board. And then here we have the DDR2 RAM. I think as standard it just came with this single stick which you can see at the front, and I added the second one with some that I had laying around from an old PC. But this is really just used for caching web pages and that kind of thing, so it's quickly accessible to clients so that you don't have to download web content continually. And then here you can see the CPU heatsink, which has got lots of fins in the direction of the airflow which is being pulled out the back, and also the Northbridge heatsink is also in close proximity to try and draw some of the air through as well. And we've got various capacitors on the board. These are all Panasonic branded FC capacitors, so that's really nice to see some high quality caps in this unit. And then here we have all of the chips for the gigabit Ethernet ports on the front, and then the pulse transformers for isolating the Ethernet from the circuitry on the motherboard. And then finally we've got the compact flash card. I fitted a 2GB card to this device, but actually I think you only need about 512 megs to run pfSense. All it does is boot the software, but then it's loaded onto RAM and everything's running on RAM once the unit's booted up. So you don't want to be writing to the compact flash all the time, otherwise it won't last very long. So I think the only time that this is written to is when you submit changes to the graphical user interface. So I think that's all we're going to look at inside this unit. There's nothing terribly exciting, it's basically just a standard PC. So let's get this out of the way and have a look at the new piece of hardware. So just before we have a look at the new hardware, I thought we'd look at the user interface for pfSense. So this is the system dashboard, which is kind of the landing page when you log into the device. So here you can see that we've actually been running this device for 504 days without it being powered down. It's running a Intel Pentium Celeron M processor, which is nominally running at 1.7 GHz, but it does throttle the speed down when it's not doing anything. And then you can see the version of pfSense that I'm running here. And it does say update available, but actually on this device it's a bit of a pain to upgrade the firmware. You have to hack around a little bit with a few things just to get it working on the Watchguard Firebox unit, obviously for the LCD to work, and also the LEDs on the front panel don't work in the same way as a standard NIC, so you have to configure those LEDs to make them work properly. But it's got various menus at the top here, so you can have a look at some of the system data. So here we've got where you can upgrade the firmware, there's packages that you can install, and various things like user managers if you have multiple users on this device and you want them to have separate logins. On the next menu item we've got the interfaces, so I think I'm using about 4 of the interfaces on the front of the unit. So the first one is the WAN interface from the cable modem. I've got another interface which is just being used for LAN but on a separate subnet to my main LAN which is running the home network. One of them is dedicated to the home network LAN, and then I've got another one which is being used for guest Wi-Fi. So you can install various packages on the unit, and one of them is a captive portal. So if anyone ever comes around my house, they can use the Wi-Fi, but rather than being on my home network, it's got a firewalled connection which only allows internet connection. You don't have to authenticate to log in to the actual Wi-Fi, but if you want to connect to the internet, when you load up any internet page, it asks you for some authentication details, and that password gets changed daily. And then finally, I've got another interface which is used purely for the femtocell, which I've got for my 3 mobile phone. Then on the next menu item, we've got the firewall, so you can set up network address translation, various firewall rules and traffic shaping and that kind of thing. And then here we've got all the services which are running. So as I said, I've got captive portal running for running my guest Wi-Fi, DHP servers, and then we've got the DNS forwarder, which I'm not using, dynamic DNS, which I am using, so I can identify my device on the internet. And then we've got LCD proc, which is a Linux bit of software for running the LCD on the front of the device. And then things like load balancing and things like that to make sure that we get good quality of service if someone's downloading loads of data. And then we've got VPN, so I use OpenVPN for my home network so that I can connect to it from other places. And then we've got the status menu item, which just gives information about what the services are currently doing. So for example, we could have a look at the traffic graph and see that at the moment we're not doing a great deal on the internet. And then we've got things like the DHP leases for all of the devices which are running on my network. And then there's various bits of diagnostics for checking whether everything's working correctly. We can do trace routes, and here's where you do some of the things like factory defaults, rebooting, and some of the configuration. So here we have the Firebox's replacement. This is the MikroTik routerboard RB2011 series. And for anyone wondering why I'm even bothering with this equipment, it's basically because I've had such bad experiences with consumer grade network equipment in the past. So other than the Linksys WRT54G, which I was running DDWRT on, once that became out of date because I had greater than 100 meg internet connection, I probably went through about 4 or 5 different routers, and they've all been really flaky or not had enough features or generally just been really poor at, say, throughput or routing or things like that. So initially I moved to a dedicated Linux box which was running some software on there, and then I moved to the Firebox, and now we've got this. And for wireless internet around the house, I'm using the Zyxel NWA3000-N wireless access points. And these are really nice access points. They've got great throughput on both the 2.4 and 5 GHz bands, and they're enterprise class hardware, so really reliable. I've never had any issues with these, and they just seem to carry on running without ever needing to be restarted. Both of these access points are connected to my network switch, so the switch at the top is a Power over Ethernet 24-port switch, and this is what they're both connected to, so it only needs a LAN cable to connect them up. And then underneath the Power over Ethernet switch, I've got an identical model, but this one doesn't have the Power over Ethernet capability. And then also I've got a lower end NWA3000 wireless access point, and this is the one that I use for my guest Wi-Fi. You're right, Tommy, it's a little bit warm today, isn't it? Having a little relax on the bed. So let's have a look inside the box. Right, so immediately you can see this is much smaller than the Firebox. It's not going to take up much room in the network cabinet. We've got, 10 Ethernet ports on the front. I think the ones on the left here are Gigabit Ethernet, and the ones on the right here are Fast Ethernet. Also in the box we've got a power adapter. We've got a box of screws and feet. And then we've got the rack mount ears. I'm not sure if there's anything else. We've got a little instruction book. And what's this, a micro USB to USB connector. So I'm not sure what you can plug in the USB port on there. We'll have to have a look at that in a moment. Right, so here we have the device with all of its accessories. It does come in various form factors, so you can buy it in a desktop model or the rack mount format, or in some smaller versions as well. And this is running a 600 MHz CPU. It's got 128 megs of RAM inside, and then we've got the 5 gigabit Ethernet ports and the 5 Ethernet ports on the front. We've also got an SFP connector, so you can use an optical interface as well, and then a USB port on the front. If we have a look at the rear, on the right here we've got a ground post if you want to ground the chassis. We've got an RJ45 port here, which I think is for a serial interface, and then we've got the DC inlet here for the power brick, and it supports input voltages between 10 and 28 volts. And then we've got a reset switch here, and then it looks like you can fit a mains inlet here. So that's something that we might investigate later on in this video, because I don't really want to be using these power bricks. I'd like to just use an IEC connector to keep everything standard. So one thing that got me a little bit excited when I was just reading through this sheet is that you can power the device from Ethernet port 1, and that would have been really nice if I could have put this underneath my network switch, connected the gigabit port up and powered the device without any external power. But it turns out that this doesn't support the 802.3AF standard for power over Ethernet. It only supports the passive power injectors, which I don't really like. If something's going to be power over Ethernet, it should support the 802.3AF standard, which most professional hardware does. You can also power devices from Ethernet port 10, but again this is power injection rather than 802.3AF. We've also got an LCD on the front which you can use to configure the device and also display how much bandwidth you're using and that kind of thing. But I think what we're going to do is we're going to take the cover off this and have a look to see if I can modify it to have IEC inlet on the back of the device. Right, so I've just taken the cover off the device, and it looks like we've got loads of space here for a power supply, so I'll have a look through my box in a minute to see if I've got a power supply that we can fit in here, and also an IEC connector to fit at the back. So just looking quickly at the motherboard, we've got the CPU here under this heatsink, which is an Atheros AR9344 600 MHz 74K MIPS CPU, and that's running the whole device. We've got a couple of DDR SDRAM chips here. So this model's fitted with 128 megabytes of RAM. If you get the desktop model, it's only fitted with half of that, so I assume they only fit one of these in the desktop model. We've got a beeper here, and that looks like a flash chip underneath this label here. And then we've got another chip here, which I presume is the chipset which is running the 5 gigabit Ethernet ports. We've got the pulse transformers here for isolation on the Ethernet ports. And then we've got another transformer here with some bridge rectifiers on this Ethernet port 1, which is for powering the device over the passive Ethernet connection. And then you can just see the cage here for the SFP fiber module. And then basically we've got the power supply section here, so a couple of DC to DCs here, probably for 3.3 and maybe 1.8 volts. And then if you buy the desktop model, you can get it with Wi-Fi, so this looks to be quite RF-y, so I think this is probably where the antennas connect to. Obviously there's passives and actives missing from this board here, and then we've just got a bit of flat flex off to the LCD on the front of the device. So just before I look for a power supply to fit inside the unit, I've just plugged in the power supply now. It's a 24 volt supply, and if I plug it into the back of the unit we should be able to see if the device is working or not. So I'll just try and get this in here. And there we go, we've got the MicroTik logo and it says it's booting now. Got a nice blue power LED here. And while it's booting, it's drawing 3 watts from the mains, so that's a greater than 10 times improvement over the Firebox, so that's definitely going to have a good impact on my electricity bill, and also it won't generate as much heat because the network cupboard does actually get quite warm. It's starting services now, and there we go. It's telling me the local IP, the user and password. So I'll just have a look for a power supply now, see if I can find something that will fit in the device, and we'll have a look to see if we can modify it to run from an IEC connector on the back of the unit. Right, so I've had a look through my collection. This looks to be the most suitable power supply that I've got. This is an XP Power ECS130US24, which is massively overkill for this application. It can supply 130 watts. This is 24 volt output, 5.4 amps at universal input. But this is a really nicely constructed compact device. They claim up to 90% efficiency on this. They've got Rubicon capacitor here, nice big one for the mains capacitor here, and then we've got some Nishikon capacitors on the output section here. Everything's, you know, kind of nicely compact, really nice build quality. The soldering and everything is really good. XP Power makes some really nice power supplies. We've used lots of them in the past at work, and some of them are built and designed in the UK, so that's really nice to see as well. But this one's quite small. It looks like it should fit nicely into the casework here. So we might have to bend these tabs down and drill through them just to hold this in place, and then we can put an IEC connector in the back here, and then all we've got to do is just work out how we get the 24 volts to this connector. It might be that I hardwire it onto the underside of this PCB. We'll have a look after I've mounted the power supply. Right, so I've fixed the power supply into place. I just drilled 4 3mm holes into the chassis, and then I used some threaded spacers on the inside, and then just bolted the power supply into place. And then I knocked out the hole which was already pre-punched for an IEC connector, soldered some cables onto there and heat shrunk them, and then put this boot on the connector. And then you can see I've taken the chassis earth directly to one of the screws that's holding the IEC connector in place with a shake-proof washer, and then another one onto a fast-on connector onto the power supply. Unfortunately, I've not got the correct crimps. I've got the housings for these connectors, but I haven't got the right crimps. I can't seem to find them anyway, so I'm going to have to wait until Tuesday for them to come in from Farnell. But that will just plug into there, and then we've got the 24 volt output here on a 4-pin header. So I've taken the PCB out of the case. I didn't want to get any swarf on the PCB while I was drilling the holes, and I thought I'd have a look to see how we can get the 24 volts onto the board, and it looks like they've already thought of that. So there's a couple of alternate places where they can put the DC inlet. So this is the same footprint as the 2.5mm DC connector on the back, but there's also a 2-pin connector here. And I have checked the continuity. You can see the positive rail goes through this diode into the power supply circuitry, but this is actually the same connector as the ones used on the power supply. So this is a Molex connector. I've just taken out the middle pin, and this is the perfect spacing for this connector here. So I'm going to get some solder wick and wick out the solder which is in these holes, and then solder this connector in place. And that's the connector now soldered in. The polarity is marked on the PCB, so when I make the cable after the crimp terminals arrive, I'll just double check all of the connections before wiring it all up. And while the PCB is out of the unit, we may as well have a quick look up close. So we're looking at the 2.4 GHz section here for the Wi-Fi, and we've got the antenna connector here, and then coming out of the chip, here we've got the transmit output. So we've got a differential pair coming out of here, which would feed into a balun, which converts the balanced output into a single-ended output, and then we've got a 50 ohms controlled impedance trace going into the power amplifier, and then all the way out through the multiplexer to the antenna connector, and then we have the return path here. This may also be the low noise amplifier, or there may be some discretes here for the low noise amplifier, feeding through this controlled impedance trace into another balun, which converts it into a differential output here for the chipset. And if we move to the left here, we can see all the matched length tracers, which are making sure that the signals arrive between the chips at exactly the same time. And you can see up close, these are 0201 components, and they're really nicely soldered. No problems with the reflow here. And then we've got one of the DC to DC converters here. This is based on the Lighton LSP5526 2-amp synchronous buck converter. So we can see the input capacitors here, and then we've got some large ceramics. We've got the inductor here and the freewheeling diode, obviously the controller here, and then a high quality polymer electrolytic capacitor. So these are quite expensive, very low ESR and really high performance. And then we've got a big ceramic on the output as well. And then just at the back here we've got the RJ45 connector for the serial interface. It wasn't clear what type of interface this was, but it turns out it's just standard serial, and they're just using an RJ45 connector for convenience. And then we've got our power connectors here, so we've got our reverse protection diode here, and then we've got some protection circuitry which is making sure that if the voltage goes above 30 volts the device turns off. And then just near the flat flex connector for the LCD, we've got a little chip here. This is a ZT2046, and this is just the controller for the resistive touchscreen. So it looks like the signals for the LCD for actually driving the display are driven directly from the main processor, and it's just got this helper chip here for reading in the 4-wire resistive touchscreen. So I think that's all I'm going to do on this video for today. It's already getting quite long. So what I'm going to do in the meantime is try and configure the device for my home network and get to grips with all of the software. And then when the crimps arrive, I'll make the cables to go inside, and then upload a video showing that and also a bit of an overview of the software. So if you enjoyed this video, please give me a thumbs up. If you didn't, give it a thumbs down. Don't forget to comment down below and subscribe if you haven't already, and thanks for watching.